Right? So we're trying 2023 here, right? Right, so let's take a diagram, put in all the forces, and then we're gonna move up. So I'm gonna do the whiteboard, right? And then we find everything that we do. Let's pick up the diagram. Most important thing is to get a diagram, right? We get a diagram right, then we have some proof of being able to work the calculation. Right? So we got 23 here, right? All right, so let's see how it works out, right? Let me just get back the question. This was one of the harder ones, huh? Yeah, I guess some very complete in last year. So we have our diagram. Right, we have a ring. Right, here is 40 degrees. Diagram shows a fixed spool AB inclined at 40. The string which passes through the smooth pulley over the smooth pulley is attached to the ring at one end. Right, going over smooth pulley and attach to a ring at one end and attach to object Y. So obviously the object Y here has a mass of 115, a weight of 150, has tension here and tension here. Right? The coefficients of friction between the ring and the pole is 0.3. The ring is just about to slip. What direction will the friction act in? If this ring were to slip, it will slip down, right? So it will have friction acting this way. Right? The friction will be 0.3 R. There's contact force. R. Did they give us the mass? No mass, we have to find that later on. So we have mass. So we have mg. Yeah, and the ring attached to the pole. About in equilibrium, so it in contact. But even if it's still in contact, it has friction. Reaction causes contact force, right? Right, so we have our label diagram. And of course we can see that law, right? What's the first calculation that we have to do? Find the mass of the ring. Right? We had to get M. So before we start doing anything, of course, we know we have to resolve, right? So we will have to resolve mg. We're resolving mg perpendicular to the plane. So that'll be mg cos 40. And down here, I like to put it as a broken line because it's a component. That'll be mg sine 40. Right. That system there is in equilibrium. So what we know about the order to get the mass, then the normal reaction, right? So based on our diagram, what we could figure out, what we know. Look at all the forces and things. We can figure out T. T is what? T is equal to 150 because this is in equilibrium as well, right? So we know, so T is equal to 150 newtons. So what we had to do T now? Right, very good. I like how you're thinking. We had to resolve T to get it into this plane here. So we had to resolve T. We know the value for T. So we had to resolve T along this plane. Take your time, right? Remember T parallel to this. So we could figure out the angle here. Think about it. So see if we can resolve T from a. See if we can resolve T, and then that might help you find M. Right? I don't think we could find, you had to find M and R. You had to solve simultaneously. Why did you? Nice. Nice. All right. So resolve it. So resolve T, right? Saskia, don't sleep there. Resolve T from a parallel to the plane, perpendicular to the plane. If you're a little confused, pick a right angle triangle right here. You have T, all you have to do is figure out any angle. You know here, so you know here, or you know here. Try it earlier. There's one more like this in the whole here. This is one of the few where we get to solve simultaneously, right? Right? But when you're solving, solve M first and then find M first and then but it wasn't right? So it's up to you. Here is 40. Here is also 40. If you want, you can complete your triangle here and say here is 40 as well. Right? And we know adjacent is our cos. So the component here, I just extended this earlier. the component here will be T cos 40. And the perpendicular component acting here, right? I know it might be a little squeeze up there, but here is T cos 30, and here is T sine 40. Yeah, that's okay. If you use 50, then you will get T cos 50, and cos 50 is the same as sine 40. Right? So it might be looking a little confusing there, but I'm gonna enjoy it. I'm gonna ship everything now back to the horizontally, right? And so R acting this way. Here is mg cos 40. Here is T sine 40. Here is 0.3 R. Here is T cos 40. Here is that's going down when you have one, right? Mg sine 40. So I took this same diagram with 1, 2, 3, 4, 5, 6 forces, and I put it here for you. Right? And now you should be able to, it's at equilibrium, it's about to slip. Solve for R and theta. Sorry, solve for R and M. Get your equations and solve it, right? Grant, you okay with this? Right? Get the equations and solve simultaneously, right? Anybody find the board blurry and the sound glitching? If we get in trouble, just here, let's log out and log back in, right? The board blurry for you too, Grant, Killen, Ka. But it's not telling, looking good here. So log out and log in, just allow us here. All right, let's see how it went now. Any answers? Any answers? So we had to get the equation. We know T is 150 and we're using gravity as 10. Right? So that will be M by 10 sine 40. I'm trying to avoid rounding off, so I'll leave it as it is, right? Is equal to 0.3 R plus T plus 150 cos 40. And the next one, R is equal to 10M cos 40 plus 150 sine 40. Or we could really do is plug M in here, plug R in here. Right. Could have a little delay now, but right? So that would be, so I'm gonna substitute for R, right? I'm gonna substitute R in here. So I'll get 10M sine 40 is equal to 0.3 R, sorry, is equal to 0.3 by 10M cos 40 plus 150 sine 40 plus 150 cos 40. What's like out now? Tell me where you get M. Tell me where you get M. Much all you got? Right, well, you want to simplify it a little better, right? So that'll be 10M. If you do like to work with the sine 40, go right ahead and multiply and work it out, right? This is 3M cos 40 plus 1.3 by 150. 0.3 by 150. Huh? 45 sine 40 plus 150 cos 40. So I'm bringing the M's on that side. I'll get, well, I factor out that M one time. I'll get 10 sine 40 minus 3 cos 40 is equal to 45 sine 40 plus 150 cos 40. So M is equal to 45 sine 40 plus 150 cos 40 all over 10 sine 40 minus 3 cos 40. How much you got here for your mass? Saskia is still blurry. Yeah. I don't know that. I'll just write a little bigger and see if that will help a little bit. Control get fair. When you're done, just solve for R. Right? I just do it like this, so no little or no rounding off, right? For the mass, 34.8 kilograms. and then solve for R. Anybody get this online when you solve? 34.8 when you solve it. Yeah, what you got here? What you got here for R? Check it and make sure. Huh? Just check it and make sure. 363. Right, just check it and make sure. Right, let's go again. Take a look at the next part. Right, when I finish, take a look at the next part. I'll draw a diagram and we'll start to solve it, right? The car moving down incline. Taking up this diagram, right? I see here that the part B. Right, they give you a tree. They give you 3,500 kilogram automobile. So I'll just put in the weight just in case we need it. Travels down an incline at a road and they give you the speed 20 meters per second. Right, if the driver jams the brake, causing the wheels to lock, and the coefficient of friction between the wheel is 0.5. So let's say, of course, we have R here. Right, I just put in R like this. Right, and we have friction, mu R. Right, and they gave you mu. Right, they said mu is 0.05. So you have this scenario here, and they want you to find the deceleration of the automobile after the brakes is applied. And then the distance the tire will skid on the road. Right, I'll give you a few minutes, try it. Right, if you want to send answers, send it. I'll take a look at it. Right, so you gotta think about what you have. Right, you gotta think about what you have. Deceleration means it's slowing down. So think of what formula you're going to use to find deceleration. You have mass, you have things that you need. Right? Just want to point out one thing. If you decide to use this, remember this acceleration here and the resultant force in the same direction. Right? Please remember, this is just not force, this is resultant force, right? Try it. I'll give you 5, 6, and then find the distance the tires will skid on the road. Right? That's basically how long it will take. Right? Before it stops. Right, so I'll give you a few minutes, take a 10 minutes. Just message your answer. So now you're finished, right? Something. Make sure this one. Nothing. What they ask for first? So deceleration, you're going to use F is equal to MA, right? So A is equal to, well, D, you get minus. You just get minus, right? Right? We know the mass, right? We know that the mass is 3,500. But we had to get the result on force acting. So we had to resolve this. So that'll be 35,000 times 10. So the resultant force acting is subtract those two. That'll be the resultant force acting. Oh wait, we didn't get R, sorry. So we had a result here, which will be taking up this, right? So that'll be 35,000 cos 10. So that's R. So now we know 30. Yeah. Yeah, equal to R. Well, why is acting vertically? No. Remember, the weight acting vertically downwards, but the component of weight acting perpendicular to the plane, which is equal to R. That's why I rub off the weight here for you. So you'll end up with 35,000 sine 10 minus mu. Mu was 0.5 by R. R is 35,000 cos 10. Nobody online anything? But minus this whole thing minus 0.32. I put D for deceleration. I put E, right? You should know it's acceleration. Deceleration. So now, what I do now to get distance. So far, just think about a normal question. Normally, when they give you something, I use it, right? And we have initial velocity. So in part 2, we have the initial velocity. And you want to what? You want to find how many tires skate, right? So when the tire stops skating, what's the final velocity? And we have deceleration, which is minus 0.32. And what you want to find? Distance. So you want to find us. So which equation you'll use? So you'll use b squared is u squared plus 2as. Okay, why not sure about it? Right, when you work it out, solve for s. S will be v squared minus u squared all over 2a. So that'll be 0 squared minus 20 squared all over 2 by minus 0.32. Then let's go to the next one. How much is that? . Okay, let's have a part 3. Because what's the resultant force acting on the fan right now, car right now? And the one up. Along the plane. Right, remember, we have all the forces along the plane, so you could rub off this angle and write it like this now and see it. The resultant force acting is the difference between these two. No other force is acting. How much you got here for this on the tires will move? How much? 625? 625 meters. Right? It still have more. I thought that was it for part number 5. The last part in number 5, the loss in kinetic energy if the car moves 5 meters after the brakes are applied. A half mv squared. Right? So the part 3. So part 3. Right? We know that the loss in kinetic energy, right, is equal to, you can just use a half mgh. Right? You can use that as well, because remember, it drop a height. So the loss in kinetic. So it drop the distance here to here. Here to there is 5 meters. Here is how much degrees? 10. So if we know the drop in height, we can work out the loss in kinetic. Okay? Yeah, should have to work out here. Right, but if you use this one here, what you would use to get here? Cos. You would use cos 10, sorry, sine. You would use sine 10 is equal to opposite over hypotenuse. So that height will be 5 sine 10. So the loss in kinetic energy is the loss. The loss in kinetic energy will be m g h. How much is that? How much? 30,000. 30,388. Right, as you were saying, we could have also done the next way. If we know the velocity here was 20, we had to find the velocity here. So we know the change in velocity during this 5 meters. And then that change in velocity, sorry, you can use the loss in kinetic as the change in, you can use a half m by velocity 1 squared minus velocity 2 squared. So you find the kinetic here minus 2. Should be the same answer. Right? And you know the little deceleration here, so you should be able to find the final velocity. Pause us here and see it. Right, when you're done, let's go to 6. Right, break up six, see what kind of question it is. Kaden, you do anything? Right, try number six. What type of question is number six, Kaden, 6A? Six A is a what? All right, Gina, pay attention. All right, go ahead, try number six on order. Try number six. I guess in case you're now tuning in, it's 2023 we do it, right? We are number six now. I think I put that right here. Are you done? Right, let's correct this one out. What type of question it is? Right, projectile. So you didn't do it here?
Try.
Oh. Online or I heard them try. Hope this will get you. Saskia is still real bad. Now, grand watching now. Apology. And Kaylee on she phone talking to somebody. I don't know about it's Saskia and Nasir. Right, so again, nice diagram is always help. At a point P, a Gulf hits a Gulf wall of mass 46 grams at an angle of 35 degrees to the horizontal. The ball travels in the air until it hits the ground at point Q 20 meters away. So it looks like this, it travels something like this. Right, here's P, and here's Q, right? Here to here is 20 meters. Right? The mass of the ball, they gave us the mass. The angle is 26. Right? Here's 46 grams. Oh wait, I write the wrong thing in. 35. Right. Calculate the speed of the ball. Well, if you remember, you can work it up, right? I'll show you both ways actually, so you'll be convinced to just use the equations of motion, right? So you want to get the speed of the ball, u. There are two things you can do. I gave you a formula for total range. I can say R is equal to, I think it's 2u1, 2ug on sine theta or something. Huh? No, not the long one. R is equal to, check it now, check the horizontal range. The second formula I wrote to something. No, not the long one. The long one is for Y. It's to find the vertical. R is equal to U cos theta by, no, what? T was what? T was 2 something. T was the time to reach maximum height. So that was U sine theta on G. And that will be the time to reach here, so it's double that. So I think the formula is R is equal to U sine 2 theta all over G. Right? But that's the formula you have to memorize, right? So you know R, you know theta, and you know G. You can solve for U. Right? But if you don't want to memorize that formula, here's what we could do. We could use the equations of motion, right? We know the horizontal displacement. So we know the horizontal displacement. Let's call that X. X is 20 meters, right? We know the initial horizontal velocity. That is U cos 35. And we know the initial vertical velocity, U sine 35. Right? The formula for X, we know that speed is equal to distance on time. So if they ask us to find speed, right? Speed is distance on time, right? We know X is 20. We don't know T. We don't know T. So we have to find the time for the journey, right? We have to find the time for the journey. Let's make sure I didn't forget nothing. I feel like I forgot. Yeah, we will have to find time using this, right? Because remember, from here to here, displacement is 0. Vertical displacement is 0, right? The initial vertical component is U sine 35. And we know that gravity acceleration is minus gravity because it's going up first. So we could solve for T. Right? We could solve for T. So S is 0. U is U sine 35 by T. In a quadratic plus a half GT squared. So you see we have a problem here. We will have to I had to use this instead. How we do now V. Right. So yeah. So we gotta use the proof. Yeah, we gotta go back and yeah, we had to go back and use it. No, we had to go back and use the formulas I gave you for R and thing. So you had to learn it in this case. What is horizontal range? What was it was 2u sine theta on g, sine 2 theta on g. All right, so what I gave you then? I gave you what? R is u cos theta by t, right? And I gave you t time to reach maximum height was what? U sine theta on g, right? So let's just say the time for the whole journey will be 2 of this. That's okay? So therefore, the time that they want here is this whole journey here. So R is really u cos theta by u sine theta all over g. 2 of that. That's okay? There's the time that they want for the whole journey, right? And just plug in the values you have. So you have R is what? R is 20. U is u. Cos theta is, let's use the identity to be easy. I mean, there are no trick problems. 2 sine theta cos theta, u by u squared. 2 sine theta cos theta is sine 2 theta. So it's u squared sine 2 theta all over g. So this is 20. We don't know u. And we know that theta is 35. And gravity is 10. Cross multiply, solve for u. U squared is equal to 2. U squared is 200 all over sine 70. U is the square root of 200 over sine 70. How much is that? $14.6. Right? So it's a little too much work to start here and develop the equation. Right? So we will have to learn at least the easy one, that learn horizontal range and time to reach maximum height. Part 2 now. Draw a label diagram to determine the position of the ball after 1 second. Draw a label diagram. Right? You must show the ball's vertical distance from the ground and the horizontal distance from P. So I don't know the answer, but watch what they asking for, right? And the ball traveling here. So they want to know when T is 1, I just pretended, T is 1 here. They want you to show the vertical displacement and they want you to show X as well. Right? Use the equations of motion and find that, right? Just do me a favor now. Just tell me what this was there. What was 2 by 14.6 sine 35 all on 10? Two by 14.6 sine 35 all over 10. 1.67. Right. So the whole journey took 1.67. Here's halfway, which is less than this, right? So 1 is somewhere on this side. Right? Just the average. But so let us find y and x. Go ahead. How you find y? Which equation you'll use to find y? Second one. And which one you'll use to find x? Now you don't know final, but you can just use distances speed by time. Right? Try that first. I'll go quick now because I'm not sure to do anything online, so I can't wait for them. Right, so here's one of the cases where the equations of motion is a lot more work than just using this little formula here, right? The last part is find the speed and direction of the ball just before it hits the ground. Speed and direction of the ball. They want it when it just before it hit the ground, so that's like right here. Right? They want the speed and the direction. So you want alpha and V. Right? Take a 5 minutes and see if we can go to them. I lost my pen. We finished at the lawyer, let me sleep a little long. I just walk right in. right? So we got correct in our part 2 here, right? Part 2 is they want you to find x and y there. So let's try to find y. Y is the vertical displacement. U is the initial vertical component, which was u sine theta 35 multiplied by t is 1 minus a half, I think g is 10, right? By 1 squared. All right, I'll have a calculator. Nobody here? And then you get y. And then do the same thing and get x, right? You're using speed. So remember, speed is always the same horizontally. Speed remains the same. 14.6 cos 35 multiplied by 1. Right? That'll be x and y. Then to find this velocity, we need to get, at that point, we need to get the vertical component and the horizontal component. So we need to get the horizontal squared plus the vertical component squared. And then we can find alpha. Alpha will be tan inverse the vertical component over the horizontal component. But you have this y. Picking up this, right? 3.36. 3.36 and 3.37, sorry. And x is what? Right, so it's coming down, right? X is what? Hopefully less than 20, yeah? What do you get for this x here? $11.96, thank you. Right? So that's the answers there. Now you want to get the vertical velocity. So remember, just see what they're talking about. Let me show you understand what they're talking about, right? When the part come here and the ball hits here, the ball is traveling at a velocity, and that velocity is a tangent to the at that point, right? So that's the velocity they want. At that point, the ball also has a horizontal velocity and it also has vertical velocity. But what they want is the actual velocity. So to get the actual velocity is the square root of the horizontal squared plus the vertical squared. Okay, so find the horizontal and then find the angle. You can find the angle between here and the horizontal. Right? Actually, we know what the horizontal is already because that's still constant, right? That's 14.6 cos 35. 14.6 cos 35, that's the horizontal. To find a vertical velocity, we could use this. That's just before it hits. We could use this. Oh no, this one will be tricky. Or we could even use the first one, v is equal to u plus at. We know the time for the whole journey is 1.67. Right? So we could use the vertical velocity. It's 14.6 sine 35. That's u minus minus 10 by t. T is 1.65. Right? T is 1.65. How much is that? Well, I just finished all the question. I remember we by mistake. Oh, okay. X was on X and Y, right? Y was 3.3 something, and X was 11 point something. Well, there you go. I'm becoming I make a mistake and rub off X and Y. This X and Y. I make a mistake and rub off this side. Just check back, you can check back, but X was to find Y, I use this.
Yeah, I guess so.
17.3. And use U as 14.6 sine 35. T as what? Now, sine 35, the component. Now, oh, so what they want is this velocity here. Watch. When the ball hits the ground, they'll be traveling at this velocity. They want that V. So you need to find the horizontal, vertical, and find the component. How much is this? Oh, Saskia, now come back. The next two people now answer. Next three now answer. You could have 4 people there. Huh? This is 12. And this is what? Negative. There's 1.67. This one, Saskia, vertical. Oh, down, no. All down. I'm not sure what he signed just now. Something looking wrong there. The speed here, it will increase until it's 0. And then it begins to go down. So because it's going down, it's supposed to be plus. Just check something, somewhere. If I use V is equal to AT, the initial velocity is 0. Right? The initial is 0. Gravity is 10. And time is half of this. 1.67 divided by 2. How much is that? Huh? 10, yeah. 10 by 1.67 on 2. 10 by 1.67 on 2. 5 point. 1.67 divided by 2 multiplied by 10. Take it back one more time. I see answer again, but negative. Right? So the negative sign means the direction change. Right? All right, yes. So at this point here, the horizontal is here, the vertical is here, the actual velocity is there. So yes, Saskia, that's correct. The negative sign just means the change direction and going down now. So here is 12 squared, and here is minus 8.35 squared. Right? Are you okay with that, Saskia? Huh? Y was 11 point something. Saskia, I rub it off, right? But what was the answer for y again? X was 10 point something. X was 11 point something. Y was 3 point something, yeah. Y was 3.37 and X was what? X was 11.96. 11.96. Yeah, you use that. So Y correct 3.3 something. Well, it must be here. All the one downstairs and rub it off. Go back on the thing and check it. And if you want to just pull back a little bit. And B is how much here? What is B here? (14.62), right? So that is the velocity as soon as it hits, and then you need alpha. Alpha is the angle. That's the angle here I was showing you. Right? That's tan inverse the vertical over the horizontal. That'll give you your angle. What's this house here? (24.8 degrees). 0.8? 34.8 degrees. Okay. All right, so that's the module 3. Right? That's the module 3, and that's what the questions will look like, right? Right, so you get them the speed and direction. There's the angle it makes to the horizontal. There's the angle it makes to the horizontal. Right. Take a good break before physics because today we're doing everything over electric. Take a good little break before physics, right? And we'll do the one lesson. Yeah, a good break, so make sure you're fresh for physics. Right, make sure you're fresh for physics.